Right, millennium problem number 5, the Poincaré Conjecture. Henry Poincaré, famous mathematician. Basically, it comes down to a visualisation of mathematics again. We're talking about shrinking a loop round a three-dimensional sphere, essentially, but we're using mathematics to do it. But I'm not going to use mathematics to answer this question. Not in the strictest sense, okay? I'm going to use the visualisation. The whole point of visualisation is so you can see the numbers working, rather than studying the numbers and the relationships between them, which can sometimes obscure it, because at the end of the day, we're just talking about something simple that we can all see, okay? So basically, the example used on the Clay Math website is a donut and an apple. Theoretically, it's possible to shrink an elastic band, for example, round an apple to a point. Mathematically, you can shrink it to a point, so to speak. But if you use a donut, the opposite example happens, and either the donut or the rubber band breaks. Okay, this is loop shrinking, basically. As I say, we're actually talking about mathematics here, but it's easier to see it rather than study the numbers themselves. Okay, so Poincaré said, okay, he essentially knew that a two-dimensional sphere is characterised by simple connectivity, which is what we call this principle. He also assumed that a three-dimensional sphere is simply connected, but he was unable to prove it. So it comes down to an opposite answer as usual. Is a three-dimensional sphere simply connected or not simply connected? And it comes down to the basic idea that Clay Math website, Clay Mathematics Institute, want one answer when there's a possible three. Okay? It comes down to an opposite answer really simply. Was Poincaré's conjecture correct or not? That's the opposite answer that it comes down to. But there's actually three answers. There's a neutral answer as well, and two opposites, all simultaneously and theoretically possible, whether you like it or not. The fact that I can say them on camera means that they're possible, in my opinion, so to speak, you see. So Poincaré was trying to test this loop shrinking principle on a three-dimensional sphere, okay? But he couldn't prove it either way. And I think the reason for that is 3 dimensions requires 3 simultaneous answers. As I've said before in the Navier-Stokes equations video, 3 dimensions doesn't mean 2, it doesn't mean 10, it doesn't mean 15, it means 3. Okay? So when you've got 3 dimensions, you've got to have 3 possible potentials, haven't you? Well, according to my theory, you have anyway, but if you think about the loop shrinking thing, right, is a 3-dimensional sphere simply connected? I'm asking that simple question. This is the question that the Clay Mathematics Institute are asking. Okay? There's a possibility, in theory, for the 3-dimensional sphere to be connected, simply connected, not simply connected, plus neutral simultaneously. If you try and prove me wrong, I'll say I'm wrong, right, and neutral simultaneously. As I've said before 10,000 times perhaps, I know this is annoying, but this is a theory of everything, okay? This is a theory that answers and explains everything. I'm not stuck in mathematics singularly, I'm not stuck in physics singularly, or philosophy either. I'm a philosopher first and foremost, and that's why I've got this opinion on it, because this is pure thought rather than the singular study of any particular discipline. I'm not saying there's anything wrong with the singular study of disciplines, such as 2 plus 2, as I've used before, is 4. That's fine if it's got a practical application, but in pure theory, ultimately, 2 plus 2 is 4, also not 4, plus neutral simultaneously ad infinitum, which means forever and ever, as I've said before. And that's the pure theory. I mean, the only reason I'm trying to explain this whole theory is basically just to show that in abstract theory, there are always 3 potentials, whether you like it or not. You can either like it, not like it, plus neutral. Once we've got this out of the way, and perhaps this has been accepted and stuff, I mean, it's nothing to do with me really, I'm just the vessel, as I've said, cliches that may say, I'm just the vessel for this theory. It just happened to me and I'm just trying to put it across the best way that I possibly can. And that's the Poincaré conjecture basically. You've got 2 opposites. If you shrink a rubber band around a donut, it breaks, one of the other breaks. If you shrink around an apple, you can shrink it to a point. Which one relates to a three-dimensional sphere? You know, they both do simultaneously, plus neutral. If you want to prove me wrong, like I say, I'm right, wrong and neutral simultaneously. As I keep saying, this is just about pure pedantic thought, I suppose. I'm the ultimate pedant in a sense. But I mean, I feel I have to be, because I want to know. I wanted to know, you know. I mean, I feel like I do know, so to speak, now. But this is what happens when you really, 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 really think about it. Okay, and that's the Poincaré conjecture. There's three simultaneous answers. 3 dimensions requires 3 simultaneous answers. If you'd like to read more about the Poincaré conjecture, there's a Poincaré conjecture essay on my Millennium Problems page on protheory.com. Okay? And that's about all I've got to say for Poincaré conjecture today. If I get any more questions about it, I'll try and make more, and I'll watch this back and stuff and see how I can possibly improve it, which I'm sure I can.